More about statistics. The t-test is very, very important. It's like the grandfather of practically all the following statistics analyses. So remember that the t-test is like the grandpa. You're only looking for two things in all of statistics. One is a significant difference between the group means. The other one is a significant relationship between the variables. But we're going back to the difference between the group means here. If there's only two groups, you're going to use one of the t-tests, right? But what happens when you're comparing more than two groups? That's when we're going to start using something we call the ANOVA. And the ANOVA is an acronym, I believe. That's the right word for analysis of variance. So you know what variance is. You remember that. That was that crazy formula where you got to take each individual from the data set, minus it from the group mean, square that difference, divided by the sample size. Since we're minusing 1 here, this is a sample variance. But remember, variance is a formula. It's just going to be a number. The bigger the number, the more spread out the data is from the mean. So we're going to analyze that variance. Again, variance is the spread of the data away from the group mean. A big number means it's widespread data-wise. A small number means most of the data is close to the mean. And variance in general, think about variance. Why do scores vary? Why do some people get low scores? Why do some people get high scores? That is variance of a variable. What is causing the variance? And that's what we're going to use with the ANOVA. We're going to try to analyze the variance and see if we can explain where it's coming from. And by variance, we're talking about the variance in the dV, which is whatever is physically measured in these statistical analyses. Find the cause of the variance in the dV. Are there specific subjects in your group that may be causing the variance of the dV? Example, the dV was push-ups, and you had two groups, right? You had the United States Marines, and you had, 10-year-old Girl Scouts. Of course, that's where the variance is coming from. And that's because it's the grouping of the subjects that you can explain the variance in, right? If they're in the Marines, they're going to do high number of push-ups. If they're Girl Scouts, they're going to do low number of push-ups, probably. Okay, so it's the grouping that causes the variance. So you're trying to explain as much variance as you can in the dV scores. So this goes back to the group means. We're looking for group mean differences. So is the grouping causing the variance in the dV? What you do is you split that dV into separate groups, right? So if you're checking for push-ups, you're going to have a little partial dV push-ups for the Marines, and the other part will be push-ups for the Girl Scouts. So you're splitting the dV into groups is what you're really doing. And when you do that, you're going to have more than one variance. You get one variance per group. And that's the same as means. You got one mean per group, you got one variance per group. And that's how all these calculations are done. They're going to compare the means and the variances of each group to see if there is a significant difference or not. Now you got more than two means. You got one mean per group. There's a minimum of 3. And you're going to compare 3 or more group means to see if there's any significant difference between the group means. You got to watch out here. There could be more than one. So let's say you had 3 groups, A, B, and C. There could be a significant difference between A and B, A and C, or B and C. But we have something called a post hoc test that will tell us exactly between which subgroups, which levels there is a significant difference. The overall ANOVA will spit out what we call an omnibus F if there is a significant difference between the groups somewhere. Example, pretend you had 10 groups. There's hundreds of possibilities where the significant difference could lay there. So it's not 100% sure. That's why these post hoc tests comes in real handy. But let's get started with the most popular ANOVA. It's called the one-way between group ANOVA. So between group is kind of self-explanatory. We're comparing means between individual groups, non-overlapping groups, independent groups, and the one-way basically means that we got one IV. So remember, an IV in an ANOVA has to be categorical with at least 3 levels. The dV is just a regular dV. It's continuous. scale score ratio. In other words, it's just a regular number. Here's a good example. Is there a significant difference in annual salaries between police officers, firemen, or EMTs? That's a perfect example of when to use a one-way between group ANOVA. The IV is group, but now you can rename the IV if you want. Like this one, you could call it profession, right? This is what these guys do for a living, guys and gals do for a living. And the DV would be, there's 3 levels, and the DV would be annual salary. So that's a perfect example of a one-way between group ANOVA. Is there a significant difference in the DV of annual salaries between the IV profession with the levels of police officer, firemen, or EMTs? Again, the one-way between group ANOVA looks for the significant difference between 3 or more group means. It's a test question. Think of it like an independent t-test, but instead of 2 groups, you got more than 2 groups. Moving on. There is something called a one-way within group ANOVA. This one, it only has 1 group, okay? It's just like the paired t-test, but instead of 2 repeated measurements, you have more than 2, 3 or more repeated measurements. That's what we call a within group ANOVA, okay? Again, it's like a paired t-test, but it has more than 2 repeated measurements. Here's a fine example. Usually with repeated measures or within groups, there is a factor of time in there. Not always, but normally there's a factor in time in there. Here's a good example. Let's say you take 100 people and you give them a pre-test for depression. That is what we call a baseline score. Anything that you measure before any kind of treatment or therapy is called baseline. Again, let's say you took a pre-test for depression, you got those scores, and then you did something. You did therapy and or meds. You're trying to reduce the depression. And after your therapy, you give them a post-test for depression. Hopefully these scores went down if the therapy or the meds worked. And then you wanted to follow up 6 months later, give them another depression test. So you got 1, 2, 3 tests, right? 3 repeated measures, 3 repeated measurements, and they all have means. And you're going to compare those 3 repeated measure means to see if there was a significant difference, whether they went up or down or didn't do nothing at all. So that's it in a nutshell for a within group. I want to show you a couple of the more complicated analysis of variance. What if we had more than 1 IV? You can, it's easy. You could have 2-way between group ANOVAs. The 2-way means that you have 2 IVs. So the DV, you can still only have 1. Remember that, only 1 DV per ANOVA. It's still annual salary. And we could look to see if there's a significant difference between salaries when it comes to the profession or when it comes to race. So you got 2 separate IVs that the ANOVA is going to look for a significant difference between. Now, this will basically run a one-way ANOVA to see if there's a difference in salaries between profession. It will run a separate one-way ANOVA to see if there's a significant difference in annual salaries based on race. And with the 2-way ANOVA, this is where we introduce you to something we call interaction. An interaction, by definition, is when one level of one IV interacts with another level of a second IV in such a way that the DV scores are either way high or way low than everybody else. So an example would be if white police officers made significantly more money per year, had a higher annual salary than everybody else. That's a significant interaction. But again, the 2-way means 2 categorical IVs. Moving on. You could have a 3-way between group ANOVA. That means you got 3 IVs, only 1 DV. So a good example of a 3-way ANOVA would be 3 categorical IVs, right? Is there a significant difference in salaries between the profession levels, the race levels, or the gender levels, and any kind of interaction between the different IVs? So moving along. ANOVA. All of these fancy ANOVAs, the 2-way, 3-way, 5-way, 10-way ANOVAs they fall under the umbrella of what we call a factorial ANOVA. A factorial ANOVA, all it has to do is have more than 1 IV or it has repeated measurements, or it has both. So when it has both, that's what we call a between group and a within group design. That's called a mixed ANOVA, and that's probably as hard as these ANOVA gets. There's a bunch of little stuff that I'm not going over in this video. One is something called a covariate. Covariate is a variable that could be affecting your groups all in the same way. Usually age is a good covariate. And I think I said it before, but if there's more than one DV, that's what we call a MANOVA. And there's a bunch of little stuff like that that this video will not contain. All right, hope that helps. MGZ out.